Audio Jungle.
Welcome back to SCI Storm, where we explore the exciting world of science. Today, we'll look at the concept of potential energy. We'll learn about the potential energy that underlies the functioning of our universe, from gravitational potential energy to nuclear and chemical potential energy. So fasten your seat belts and prepare for an exhilarating ride into the world of potential energy. Let's begin straight now. Potential energy is a type of energy that an object possesses because of its position or condition. It's like having stored energy that can be used later. Here are some simple examples to help you understand. Gravitational potential energy, GPE. This type of potential energy is related to an object's position in a gravitational field, like on Earth. The higher an object is above the ground, the more gravitational potential energy it has. When you lift an object, you do work against gravity, and this work gets stored as potential energy. The formula to calculate gravitational potential energy is GP equals mgh, where GP equals gravitational potential energy, m equals mass of the object, g equals acceleration due to gravity, approximately 9.8 meters per second squared on Earth. H equals height above the reference point, usually the ground. Example, a rock on a cliff ledge has more gravitational potential energy than the same rock at the base of the cliff because it is higher above the ground. Elastic potential energy. Elastic potential energy is stored in objects that can stretch or compress, like rubber bands, springs, or a compressed coil. When you stretch or compress such objects, they store potential energy because they try to return to their original shape. The amount of elastic potential energy stored depends on how much the object is stretched or compressed. Example, when you pull a slingshot back, the elastic potential energy is stored in the rubber band. When you release it, the rubber band returns to its original shape, launching the projectile forward. Chemical potential energy. Chemical potential energy is found in the bonds between atoms and molecules in substances. During chemical reactions, these bonds can be broken or formed, releasing or absorbing energy. The energy stored in chemical bonds determines the potential energy of a substance. Example, food stores chemical potential energy. When you eat food, your body breaks down the chemical bonds in the food molecules, releasing energy that powers your body. Nuclear potential energy. This type of potential energy is associated with the strong nuclear force that holds protons and neutrons together in the nucleus of an atom. Nuclear reactions, like fission, splitting, or fusion, combining, of atomic nuclei, can release this stored energy. Example, nuclear power plants use nuclear fission to split uranium atoms, releasing a tremendous amount of nuclear potential energy, which is then converted into electricity. Electrical potential energy. This energy is present in charged particles within an electric field. When positive and negative charges are separated, they have electrical potential energy. Example, a charged battery stores electrical potential energy, which is converted into electrical current to power electronic devices. Magnetic potential energy. Magnetic potential energy is associated with the magnetic field around magnets or magnetic materials. When magnets are brought close to each other, they can attract or repel each other due to this potential energy. Example, when you bring two magnets together, they may either stick together, attract, or push each other away, repel, due to the magnetic potential energy stored in their fields. Thermal potential energy, internal energy. This type of potential energy is related to the internal microscopic motion of particles in a substance. As temperature increases, the kinetic energy of the particles also increases, leading to a rise in thermal potential energy. Example, When you heat water on a stove, its thermal potential energy increases, and the water molecules move faster, eventually boiling and transforming the thermal energy into steam. Elastic potential energy in a bow and arrow. In addition to rubber bands and springs, elastic potential energy is also found in a bow and arrow. When you draw the bowstring back, it stores energy due to the tension in the string. When you release the arrow, the potential energy is converted into kinetic energy, propelling the arrow forward. Gravitational potential energy in roller coasters. Roller coasters are a great example of gravitational potential energy in action. When the coaster is lifted to the top of a hill, it gains potential energy. As it descends down the hill, the potential energy is converted into kinetic energy, providing the thrilling ride. Chemical potential energy in batteries. Batteries store chemical potential energy within their chemical compounds. When you use a battery to power a device like a flashlight, the chemical reactions inside the battery release the stored energy as electrical energy. Nuclear potential energy in stars. Stars, like our Sun, shine due to nuclear fusion reactions in their cores. In these reactions, hydrogen nuclei combine to form helium, releasing a tremendous amount of nuclear potential energy in the form of light and heat. Gravitational potential energy in waterfalls. Waterfalls store potential energy due to the height of the water above the base. As the water falls, its potential energy is converted into kinetic energy, generating the force that impacts the pool below. In summary, potential energy is a fundamental concept that describes the stored energy in an object or system due to its position, configuration, or internal properties. Understanding potential energy is crucial for grasping how energy is transferred, converted, and used in various processes and systems. Understanding potential energy is crucial in various fields, from physics and engineering to everyday activities. It helps us comprehend the mechanisms behind many natural processes, technological innovations, and the functioning of the universe. Whether it's the stored energy in an object's position, its chemical bonds, or its atomic structure, potential energy plays a fundamental role in shaping the world around us. Thank you for visiting us on SCI Storm to learn about potential energy. If you liked this video, don't forget to subscribe for more interesting material like this. Keep asking questions, continuing to be fascinated, and discovering the secrets of science. See you again soon.